Hello students, myself Dr. B. Sridhar, Professor, Department of ECE, MLR Institute of Technology, Hyderabad. Now we are going to discuss about fiber splicing. First of all, why fiber splicing required? It's one of the important concept in the optical fiber communication system. Practically, we know that the length of the fiber may be around 50 meter to 100 meter. So I want to establish a connection over 100 kilometer. So surely I need to join a two fiber. It's very important. So you have to join the two fiber together. So this is nothing but the splicing. The joining may be either permanently or semi-permanently. Suppose for example, the fiber is there. So if it is accidentally severed, something happened, so I can cut the fiber. After that, I have to join the two fiber to run a cable, to run a connection. Okay, so fiber joint required. Fine. Let us come to the point, fiber splicing. So what are the splicing techniques available in the optical fibers? Here we know that the splicing of fiber is nothing but joining of two optical fibers. So generally it can be categorized into two: fusion splicing and mechanical splicing. Fusion splicing and mechanical splicing. Now this mechanical splicing is again categorized into two. One is V-grooved splicing and elastic tube splicing. Now let us see one by one. Fusion splicing. Here the name itself here indicates the fusion. The fusion is nothing but, suppose this is the fiber 1, so this is the fiber 2. So here I can apply some electric arc over here. So the fiber end core may be fused, they are actually melted. Then after that we have to join these two fiber properly. So before that we should keep the fiber in the fiber holder. It is hold properly. After that only we can apply the electric arc at the fiber end. Once the fiber end melted, automatically after that we have to join these two fiber. This is nothing but the fusion splicing. You can fuse the end of the fiber and then have to join. This is nothing but the fusion splicing. So this comes under the permanent joining of two fibers. Now let us see another one. V-grooved splicing, you can call V-grooved mechanical splicing also. So here what is this V-grooved mechanical splicing is nothing but here we have the V-shaped substrate. So in the V-shaped substrate, here we can place a two fiber. This is consider this is fiber 1 and this is nothing but the fiber 2, and you can keep properly. After that you have to apply some adhesive gel to joining of the two fiber. So why this V-grooved substrate required? The sense the fiber may not move while joining the two fiber. The fiber may not move from the out of the region. That's why you can keep the fiber in the V-grooved substrate. Once these two fiber are fitted in the V-grooved substrate, after that automatically you can apply some adhesive gel and then we can join two fiber. Next one, elastic tube splicing. So this comes under the fiber may be joined semi-permanently. Suppose this is the fiber being inserted in something with the fiber 1 and fiber 2. So we have some capillary tube. It's like an elastic material. So here covering of this fiber 1 and fiber 2. So here some tube is there. So this capillary tube, it can be able to cover the 1 and 2. If you observe this one, so this 2 clamp the two fiber. After that here the fiber source, the optical source may be enter into the material and it can be reached to the fiber 2. So this is something with the elastic tube splicing. So in between this gap is there, but in the gap here the tube can be properly fitted. In that gap the light signal can be properly propagated and it can be entered into the next fiber. So whenever we want we can connect, we don't want we can remove the capillary tube. So this is something with the elastic tube splicing. Fine. Now let us see the advantages and drawbacks while joining a two fibers. So as we know that the fiber connection we need to join a two fiber. It's compulsory. So without joining a two fiber, establishment of optical fiber communication is highly impossible. So fiber join is compulsory required. So because of the joining, what will happen? So we can achieve the long distance optical signal transmission. Is a very important point of why we can go for fiber splicing. And next one, if you apply the splicing, almost we can achieve the permanent connection of two fiber. Some cases will be semi-permanent. Okay, so here this splicing provide the permanent connection of the two fiber, because we are placing the adhesive gel. Sometimes we are apply the electric arc and fusing and joining the two fiber, so it will create the permanent connection between the two fibers. Once the fiber may be joined, then signal may be transferred from one to another place, so we can achieve the optical fiber communication system. Okay, so these are the advantages behind the fiber splicing. Next one, drawbacks. If you see the drawbacks, so while apply the fusion, what will happen? Automatically the fiber end may be melted out, then we may get some loss here. So what is the loss? And suppose the fiber end is melted over here, so another end also melted over here. If we join these two fiber, may not be established the connection, and we can experience more losses than the acceptable limit. So this is one of the drawbacks in the fiber splicing. So we can experience more loss while joining a two fiber. Next one, the splicing increases the overall cost, because it's a very much cost effective one. Okay, so while joining two fiber, the cost may be high. So main point is we can experience more loss in the fiber. Second one is installation cost is high. So these are the drawbacks in the splicing. Thank you.